Are cars too boring for you? How about space? Do you want to go to space? All you need is a big tank of fuel and a fire, right? Unfortunately, rockets are a bit more complex than that. Any form of propulsion relies on Newton's third law. For every action, there is an equal and opposite reaction. If the hot gas that is shot out of the rocket is the acting force, then the reacting force is the force that sends the rocket upwards. Let's apply this to the simplest type of rocket out there, the solid fuel rocket. A solid fuel rocket is basically what it says on the tin. It's a tube that contains a single mixture that is made out of highly flammable chemicals that burn gradually when ignited. This is a pretty simple design and it's been around for a very long time, first used by the Chinese in the 13th century for war, and modern militaries use them as missiles. Anyways, when the solid mixture is ignited, it sends very hot and fast gas molecules towards the ground. The reacting force of this gas being released causes the rocket to lift upwards. Liquid fuel rockets are a bit more complex. They still rely on Newton's third law just like the solid fuel rockets, but their fuel tanks carry fuel and something else called an oxidizer. Now, an oxidizer's job is to allow the fuel to burn because when a rocket burns fuel, it needs oxygen. Unfortunately, there's no oxygen in space, so that's why the oxidizer is used. Most of the time it's liquid oxygen, but it can be other things like hydrogen peroxide. The fuel tanks, have fuel in them, but it's not like you can fuel a rocket by going to a petrol station. Most rockets either use kerosene, which was used by the lower stages of the Saturn V rocket, or liquid hydrogen, which was used by the space shuttles. Okay, so now you know what's inside the fuel tanks, the fuel itself and the oxidizer. So all you need now is the engine. This is a simplified version of what goes on. Inside the fuel tank, you have two tanks containing oxidizer and fuel. Then you have two pumps that carry these two liquids to the combustion chamber. Then in the combustion chamber, these liquids are then ignited and the hot gases that are formed when the liquids are ignited are sent downwards via the nozzle. Again, the reacting force of the gases being sent downwards sends the rocket upwards. Liquid fuel rockets are far more complex than solid fuel rockets, so why do we bother using them? They're more heavier, more expensive, and they also have a higher chance of failing. Why not only use solid fuel rockets to get to space? It's mainly because once you set off a solid fuel rocket, you can't stop it from burning until all of its fuel is used. You also can't control the amount of thrust that is generated by a solid fuel rocket. It'll just keep burning as fast as it can. In a liquid fuel rocket, not only can you adjust the amount of thrust that the rocket experiences, you can also shut it down or restart it multiple times during a single flight. But besides rockets, there are also other ways of getting to space. But that's for another time.